Section 4.3, Curve Sketching. In this section, we're going to be doing 3 different tests and using those tests in order to help us draw the graph of a function. So we are going to be drawing these graphs without the use of our calculator and only using calculus. All right, so make sure you're not just punching these into your calculator and drawing me what you see. All right, so the first thing I want to reiterate is, what is a critical number? Right, we talked about critical numbers in 4.2. So if you haven't looked at that 4.2 lecture notes on Canvas, you better do that first. So a critical number is any x value where the derivative equals 0 or where the derivative does not exist. So we're always going to be finding these critical numbers where the derivative is 0 or where the derivative does not exist. Right? So we have these 2 tests, okay, the increasing decreasing test and the first derivative test. So quite simply, okay, we talked about this when we drew the graphs of the derivatives. So if the derivative is greater than 0, right, if the derivative is above the x-axis, that means that the function is increasing on that same interval. Right? We did this backward. We did this the other direction in section 2.7, because if the function was increasing, then the derivative was above the x-axis. But now we're going the other direction. Okay? If the derivative is positive, then the original function's increasing. If the derivative is negative, then the original function is decreasing. Right? So here's our increasing decreasing test. So we don't have to graph a function and to know whether it's increasing or decreasing. We just have to look at what the derivative is doing. Right? So coupled with the increasing decreasing test, we have this first derivative test. The first derivative test is going to tell us where our function has local maxes and mins. Right? So if f prime of c equals 0, right? So we're plugging those critical numbers into the derivative. So if we have a value of c where the derivative is 0, okay, and at that point, if the derivative changes from positive to negative, that means the original function is changing from increasing to decreasing, right? And I draw that with my finger in the air, usually in front of you guys as a class, but I'll just try and use my pen, okay? So if we're going from increasing to decreasing, notice that we're kind of drawing a little max there, right? So if the derivative changes from positive to negative, then there's a local max, because we're going from increasing to decreasing, right? So if the derivative, if f prime of c again is 0, right? So it's a critical number where the derivative equals 0, and the derivative changes from negative to positive, right? That means we're going from decreasing to increasing, right? So as you do a decreasing function and then change it to increasing, you're drawing a little min there, and there's a minimum that is occurring at c. Okay? So if the derivative does not change from positive to negative or negative to positive, then it's neither a max nor a min. Now, what happens when the derivative doesn't exist? Right? A lot of times it's where there's an asymptote or where there's a sharp point. Okay? Sometimes those sharp points can still be considered maxes and mins. Right? So we're going to test this for where the derivative equals 0 and where the derivative does not exist. Right? So let me just do one example for you using the increasing, decreasing test and the first derivative test to kind of get you going on the homework. Right? So I'm going to pick a polynomial function at first. So we have our function here, f of x equals 2x cubed minus 3x squared minus 12x plus 7, right? I want to know where this function is increasing, where this function is decreasing, and where this function has a local max and a local min. So the first thing we're going to do is we're going to find the critical numbers. Right? We're going to take the derivative and we're going to find out where the derivative is 0 and where the derivative does not exist. So the derivative here is fairly straightforward, right? We just got a bunch of power rules. So the derivative of 2x cubed is 6x squared. The derivative of negative 3x squared is negative 6x. The derivative of negative 12x is negative 12. And then the derivative of 7 is 0. Right? So I'm going to take this derivative and I'm going to set it equal to 0. Right? And solve. So what I can do first is I think I can factor out a 6. I'm going to go ahead and do that to make the factoring easier. X squared minus x minus 2. Right? And then I'm going to keep going. So I'm going to factor the x squared minus x minus 2. So multiply to negative 2, add to negative 1. We're looking at minus 2 and positive 1. Right? That's where the... So if I were to solve this, okay, this is where the derivative is going to equal 0. Right? So I have 3 factors here, and I am going to be really careful to always set this factor equal to 0. Okay, so 6 equals 0, x minus 2 equals 0, x plus 1 equals 0. Now when I set 6 equal to 0, there's no solution. If I set x minus 2 equal to 0, I get 2 as a solution, and if I set x plus 1 equal to 0, I get negative 1 as a solution. So right now we have 2 critical numbers. This is where the derivative equals 0. Okay? So if we ask ourselves where the derivative does not exist, right? This is a quadratic, and the domain of this quadratic is all real numbers. So there is no point where this derivative does not exist. Right? So we have 2 critical numbers, 2 and negative 1. Now, in order to do both increasing, decreasing test and the first derivative test, we're going to do a number line analysis here. So I'm going to draw a number line. Now I'm going to put those 2 values on the number line. Okay. If we have 2 critical numbers, that's going to split our number line into 3 intervals. Right? We have an interval from negative infinity to negative 1, an interval from negative 1 to 2, and an interval from 2 to infinity. So we want to know what the derivative is doing there. Is it positive or negative? So what I would like to do is I like to do a test point. Okay, so TP for test point for all 3 of these intervals. Right, those of you who had me in pre-calc or college algebra, this is how I usually do things. Right, so I'm going to pick a test point, any number in this interval from negative infinity to negative 1. So I'm going to pick negative 2 here as a test point. Any number between negative 1 and 2, I'm going to pick 0. And a test point from 2 to infinity, I'm going to pick 3. Right? Now I'm going to plug those into the derivative, right? Into the factored form of the derivative. So the derivative has a 6, and then an x minus 2, and an x plus 1. So I'm going to put 6 here, and then 2 open sets of parentheses, 1 for each of those factors. So this is kind of like my skeleton for the factored form of the derivative. 6. Now, I put the 6 here, but the positive number is not going to change the sign of the derivative, so I kind of don't really need it. But what I want to do is I want to plug these test points into these factors. And in these open sets of parentheses, I'm just going to indicate whether the number is going to be positive or negative. So if I plug negative 2 into this first factor, minus 2 is minus 4. So this first factor is going to be negative. If I plug negative 2 into the second factor, negative 2 plus 1 is negative. Okay, so this is going to be negative. Right? I'm going to do that on down the line. Plug 0 into my 2 factors. 0 minus 2 is negative. 0 plus 1 is positive. Right? And then plug 3 in. 3 minus 2 is positive. 3 plus 1 is positive. Right? Now above the number line, I'm going to indicate whether the derivative is positive or negative. So if I do a positive 6 times a negative times a negative, overall this derivative is going to be positive here. Right? If I do 6 times a negative number times a positive number, overall the derivative is going to be negative here. And if I do 6 times a positive, the derivative is going to be positive. So here's where the increasing, decreasing test comes. Right? If the derivative is positive, then the function is increasing. If the derivative is negative, then the function is decreasing. So I know exactly where this original function is increasing and decreasing. Okay? So we're increasing from negative infinity to negative 1 and from 2 to infinity. Right? Decreasing from negative 1 to 2. Right? And this is where the original function is increasing or decreasing. Right? This is where this cubic function is increasing or decreasing, right? So it's going to start off increasing, change to decreasing in the middle, and then change to increasing again. So it's going to look like a cubic, right? Now on top of this increasing, decreasing test, we can do the first derivative test, right? So at these critical numbers where the derivative equals 0, if it changes from positive to negative or negative to positive, we have either a max or a min. Okay? So here's my critical number, negative 1. And at negative 1, it's 0. Right? The derivative is 0. But it's positive on one side and negative on the other. So it's changing. So if it's changing from positive to negative, that means the function is increasing and then changing to decreasing. So notice when you go from an increasing function to a decreasing function, you get a little max, all right? And then at 2, the derivative is 0 at 2, but at 2 it's changing again. It's going from negative to positive. So if the derivative is negative, then it's decreasing on one side, and then it's increasing on the other, right? So at 2, we have a local min. So I know we have a local max at x equals negative 1. We have a local min at x equals 2. Here's your first derivative test and your increasing, decreasing test for a polynomial function. Right? My videos have to stay under 15 minutes or they don't load to YouTube or to Canvas, and so I am going to stop here and continue the lecture in another video.